August 21st, 1986. Nightfall in the hills of northwest Cameroon. In the village of Nyos, families finish their evening meals. Fires burn low. People go to sleep. They never wake up. Something invisible had moved through these valleys in the dark, killed everything that breathed, and vanished. Because Lake Kivu is not just a lake, it's a pressure vessel. Dissolved in its deep water, held down by nothing but weight and a fragile layering of density, sits one of the largest concentrations of trapped gas anywhere on the planet. Hundreds of cubic kilometers of carbon dioxide, tens of cubic kilometers of methane, laced with hydrogen sulfide, a loaded gun, the size of a small country. In recorded history, it has never gone off. But the safety catch is thinner than anyone would like. And the finger on the trigger? That's an active volcano. 10 miles from the city. In 2021, it fired a warning shot. We'll get to that. First, you need to understand what happened at Nyos. Because Nyos is the only reason we know what this lake is capable of. Rewind to Cameroon, 1986. Lake Nyos sits in the crater of an old volcano. Deep underground, magma releases carbon dioxide, and that CO2 seeps up through the rock into the bottom of the lake, where the pressure of all the water above forces it to dissolve. Think of a bottle of soda. Sealed, the gas stays invisible, locked in the liquid. The bottle can sit for years looking perfectly still, but a lake isn't supposed to be sealed. Most lakes turn over, surface water cools, sinks, deep water rises, and gases vent gradually into the air. A slow, safe exhale every year. Nyos didn't exhale. Its deep water was denser than its surface water, a stable layering that never mixed. So the gas didn't vent. It accumulated, year after year, decade after decade. The soda bottle, filling beyond anything nature intended. And then, on the night of August 21st, 1986, something shook the bottle. Most scientists believe it was a landslide, collapsing into the deep water. The deep layer lurched upward. Pressure dropped, and the gas came out of solution, all at once. This is called a limnic eruption. It is one of the rarest disasters on Earth. The lake literally erupts, not with lava, but with gas. A column of water and foam blasted 100 meters into the air, and the lake exhaled a cloud of carbon dioxide that had been building for centuries. Here's the thing about CO2. It's about 1.5 times heavier than air. It doesn't rise and disperse. It hugs the ground. It flows downhill like invisible floodwater. The cloud rolled down from the crater into the valleys below at up to 50 kilometers an hour, silent, colorless, and completely unbreathable. It displaced every trace of oxygen. People died mid-step, mid-sentence. Whole families, in the exact positions they held when the air around them simply stopped being air. 25 kilometers from the lake, it was still killing. 1,700 people. One night. From a lake with a surface area of 1.5 square kilometers. Now, hold that number in your head, because Lake Kivu's surface area is roughly 2,400 square kilometers, and Kivu has something Nyos never had. Everything that made Nyos deadly, Kivu has more of: the stable, layered water column that never mixes. The volcanic gas seeping in from below. Kivu sits directly on the East African rift, where the continent itself is slowly tearing apart. The deep reservoir, saturated for centuries. An estimated 300 cubic kilometers of dissolved carbon dioxide. But the rift did something else to Kivu. On the lake bed, microbes have spent thousands of years digesting organic matter and volcanic CO2 and exhaling methane. Around 60 cubic kilometers of it dissolved in the deep water. Methane isn't just an asphyxiant. It burns, which means Kivu isn't only a suffocation risk. It's the only lake on Earth where the gas cloud could ignite, and where Nyos had scattered farming villages downslope. Kivu's low ground contains 2 of the largest cities in the region. One more difference. At Nyos, no one knew the danger existed. At Kivu, we know. The scientists know. The governments know. There are researchers who have spent their entire careers measuring this exact lake, publishing warnings with phrases like utmost importance. The people of Goma call it the Lac qui dort, the sleeping lake. So let's ask the question this channel exists to ask. What happens if it wakes up? Minute 0. It probably starts with the volcano. Mount Nyiragongo, 10 miles north of Goma, holds the largest lava lake on Earth. and its lava is unusually fluid. When Nyiragongo erupts, lava doesn't creep, it runs. In 1977, it moved at highway speeds. In our scenario, fissures open on the volcano's southern flank, toward the city, toward the water, and lava pours into Lake Kivu at volume, superheating the water column. Or maybe the trigger is simpler. The rift itself slips, and a major earthquake shakes the lake like a hand around a bottle. Either way, somewhere in the deep water, the layering fails. A mass of gas-saturated water rises just far enough that the pressure holding its gas in solution drops below the breaking point. Bubbles form, and here is the mechanism that turns a disturbance into a catastrophe. Rising bubbles drag deep water up with them. That water depressurizes and releases its own gas. More bubbles, more lift, more water, a chain reaction using nothing but physics. The lake doesn't fizz, it erupts. Columns of water and foam blast upward as centuries of stored gas come out of solution at once. Hour 1. From the shore, the first sign is sound, a roar from the middle of the lake, and then a white wall, fog, gas and water vapor, spreading outward across the surface. Then the wall reaches land, and the physics turn cruel. The carbon dioxide, heavier than air, slides off the lake and pours into the lowest ground available. The lowest ground is where the cities are. Goma sits directly on the shoreline. The gas doesn't announce itself. It has no color. The streetlights stay on. Phones keep working. Cars keep idling. For a few seconds, everything looks normal. There's just nothing left to breathe. People at higher elevations survive and can only watch the fog sit in the streets below. And then Kivu plays the card news never held. The methane finds an ignition source, a cooking fire, a generator, a dropped power line. Now there are explosions and fires burning inside a cloud where no rescuer can walk, suffocation and fire. At the same time, in the same streets. Day 1. Here's what most people get wrong about a limnic eruption. It isn't a bang, it's a release. The lake can keep degassing for hours, days, as deep water keeps cycling upward. The cloud doesn't pass like a storm front, it's fed. Rescue in any meaningful sense is nearly impossible. You cannot enter the low ground without self-contained breathing gear, the kind firefighters wear, and it does not exist in this region in anything close to the numbers required. Helicopters can't operate blind in gas-saturated fog. The airport at Goma sits practically at lake level. The world watches satellite images of a white stain across the border of two countries, and can do almost nothing for the people inside it. How many dead? Here is the honest answer. Nobody knows. The serious estimates for a full overturn of Lake Kivu range from tens of thousands to, in the worst modelled cases, over 1 million. The uncertainty isn't a footnote. The uncertainty is the horror. We have exactly 2 data points in modern history, Nyos and its smaller sibling Lake Nyos, and Kivu is 3 orders of magnitude beyond both. Week 1. The gas has finally thinned. Now comes the cascade, because a disaster this size doesn't end. It converts. 2 countries share this shoreline, and one of them, the eastern DRC, was already one of the most complex humanitarian crisis zones on Earth, before the lake erupted. Now, mass casualties, mass displacement, in a region where armed groups, refugee camps, and cholera outbreaks were the baseline. Survivors flee in every direction, into Rwanda, deeper into Congo, through terrain with almost no intact infrastructure. The lake itself has turned. The overturn has dragged deep, oxygen poor, toxic water to the surface. The fish, a protein source and livelihood for the entire shoreline, die en masse. The water supply for every lakeside town is now suspect. The thing that fed 2 million people has become the thing they cannot touch. And one more number, for the whole planet. Lake Kivu's deep water holds the equivalent of roughly 2.6 gigatons of CO2, about 5% of humanity's entire annual greenhouse gas output. In this scenario, a meaningful fraction of it enters the atmosphere in days. A single lake, in a single week, exhaling like a continent. The aftermath question. Hurricanes pass. Earthquakes end. Even Chernobyl, once entombed, stopped getting worse. Kivu reloads. The moment the eruption ends, the springs at the lake bottom resume their work. A CO2 seeps in. The microbes keep exhaling methane. The layers reform, and the reservoir begins to fill again, over the heads of whoever moves back. The survivors wouldn't be living next to the site of a disaster. They'd be living next to the weapon, watching it reload in slow motion. Now, here's where this story does something most disaster stories can't. We are already trying to defuse it. Out on the Rwandan side of the lake floats a platform called Kivu. It lowers pipes deep into the gas-rich water, draws it up, separates the methane, and burns it in a power station on shore. The gas that could ignite over a dying city instead keeps the lights on in Kigali. It is one of the most elegant ideas in disaster prevention anywhere on Earth. Don't wait for the bomb to go off. Unload it, one bullet at a time, and sell the bullets as electricity. But look closer, and the elegance gets complicated. Experts have pointed out that the volume being extracted isn't yet meaningful against the scale of the reservoir, and the extraction targets the methane, the carbon dioxide. The bulk of the killing cloud mostly stays down there, and there's a darker wrinkle. The deep layering, the density staircase that holds the gas down, is the only safety catch this lake has. Some scientists worry that large-scale extraction, done wrong, could disturb those very layers, pump too aggressively, return the wrong water to the wrong depth, and the mechanism built to disarm the lake becomes the disturbance that sets it off. The safety program and the trigger scenario are the same machine, separated only by engineering discipline. So where does the science actually land? Let me be straight with you, because this channel deals in physics, not panic. The most recent careful measurements suggest the gas concentrations in Kivu's deep water are currently close to steady state, not visibly climbing toward a breaking point. The researchers who know this lake best are not predicting an eruption this year or this decade, but steady state is not the same as safe. It means the gun stays loaded at the same level, while the finger stays on the trigger, because the volcano doesn't care about steady state. May 2021. Mount Nyiragongo erupts with almost no warning. Lava pours south, toward Goma, toward the lake. Hundreds of thousands flee. And then, at the edge of the city, the flows stop. The earthquakes that follow crack roads and buildings for days while scientists hold their breath over one question. Did anything disturb the deep water? That time, the answer was no. The warning shot has already been fired. It just missed. Go back to Nyos one last time. After 1986, engineers did something remarkable there. They sank pipes into the deep water and let physics run in reverse. A controlled fountain, venting the gas a little at a time, 24 hours a day. You can see it today, a plume of white spray in the middle of a silent crater lake. A bomb, diffused by a garden fountain. It works because Nyos is small. Kivu is 3,000 times bigger. There are not enough pipes in the world, so 2 million people will keep waking up tomorrow morning on the shore of the sleeping lake. The fishermen will go out, the lights in Goma will burn on gas pulled from the deep. The volcano will smoke on the horizon, and underneath all of it, the reservoir will hold, because it has always held. In 1986, the world learned that a lake can kill everything around it in a single night. The question Lake Kivu is asking, quietly, patiently, in a language of pressure and density, is whether we learnt that lesson well enough before it asks louder. If you want more single points of failure, the hidden triggers holding the modern world hostage, subscribe, and tell me in the comments which one I should walk through next.